Welcome to video number 24B in how to make a chess program in Go. I promised to go through different node types and the name of node types and what the meaning is. I will start with that, and after that I will show some tests that I did, but we will come to that. I think last time I talked about the root node. A is a root node, so no problem with that. And in the bottom we see all these numbers. They are leaf nodes, and they are probably QS nodes or evaluation nodes. When we do iterative deepening, we start with depth 1, right? So A will start with depth 1 and look at the four moves AB, AC, AD, and AE. And we'll find that AB is the best move. So the position B is the position from AB, the move AB. Now, next step is to go depth 2. And then we sort the moves. Maybe you remember, in the root node we sort the moves, and B will be the first move to test or try out. So we'll make the move AB and get the position B. B will go through its moves F, G, H, and I, and we will find that BF is the best move, leading to position F. So now we have a principal variation that is A to B, B to F. And now we go depth 3. So the sorted table in root node will start with B, and B will go to its transposition table and find F. Then we have the principal variation A, B, F, and we will continue like this. So A to B and B to F are the PV moves, and A, B, F are the PV nodes. And these moves, A to B, B to F, we call the PV line, the principal variation. That is the main line in the position. All the siblings to B, they are cut nodes. Every PV node have siblings that are cut nodes. And cut node is a node that will be refuted. CJ, CK, CL, and CM. One of those moves, hopefully the first one, J, will refute C and say you are not good enough, so you can stop search here. It's a beta cutoff, and that's why C is a cut node. And its bad value will be backed up to A, and A will ignore C and continue with D, AD. If everything continues as expected, D is also a cut node, and E is also a cut node. The children to C are called all nodes, and if everything goes as expected, we will only examine J, because C will be beta cut off. So J will not be cut off. That means J will search through all its moves, JN, JO, JP, and JQ. What will happen if J is cut off? Well, then C is still alive and will continue with K, and we hope that K will go through all of its children instead, and so on. If all the children to C, J, K, L, M, are cut off as well, well, then C is the new PV node and will be researched, because when we search a PV node, we have a wide alpha beta window, because we want to have an exact value, exact score for PV nodes. B is searched with a wide window, then C, D, E will be searched with just one step in alpha beta window. It will be beta minus 1 up to beta, meaning that you can never get a score between alpha and beta. The score will always be a lower bound or an upper bound. We took a risk that everything will be as expected, and we will get a much faster tree search, but sometimes it fails. And that's why we need to research C with a wider alpha beta window. Now C is the new PV node, and the new PV line will be A to C, C to, let's say, J to N. And now we will take a look at some tests that I did. Here are the results. As you remember, we searched with depth 8 the last time, and we had these two positions, starting position in chess and the London position. We checked alpha beta with killer, it's a better move ordering, alpha beta with killer and iterative deepening, even better move ordering. It goes much faster with good move ordering. Now the timing was so fast, so now I increased the depth to 10, and now I also have 4 positions. The 2 new positions, Philidor and English, are introduced here. The difference between these positions is the number of moves you can do. So in starting position you have 20 moves. In the Philidor position you have 28 moves, if I remember correct. And the English position is 30 moves. The London position is 50 moves. Now, the start position in chess is very different from the others, as you can see. Without transposition table, we have 3 seconds for starting position, and that goes down to 1.3 seconds with transposition table. And now we have transposition table with, well, a quite sloppy move ordering, but at least we put the transposition move first. We take some advantage of the transposition table. And the same trend is for all these positions, a little bit different, but they all goes down in time. And as the move node per seconds are about the same for all of these tests, we know that the number of nodes visited is what gives the time. I also should add that this test is not perfect in any way, so we can get a little bit different values if we do these searches again, but the trend should be the same. When we introduce transtable, the difference is so big that we don't need to have very fine-tuned tests. One thing that is new here is the EBF, effective branching factor. The effective branching factor, or I should say the branching factor, is how many moves you have from a position, and that is all the branches we need to examine. And effective branching factor is what we really is searching, because we are using alpha, beta, and so on. The numbers I get here, 4.66, 5.13, and so on, they are very low. They are surprisingly low. But okay, I expected 6, around 6. That was what my memory told me. It should be about 6, because we didn't do anything special here, just normal stuff. When we introduce the transposition table, we get 3.98 and 3.55, and this is far too low. So I expected a bug here. Anyway, that was a bug, yes. If we open the code here, we can see we have generate all non-captures. We have 2 functions, generate all captures and generate all non-captures. And all these that are moving to empty bitboard, they are okay. But generate pawn captures, It's very misplaced here. It should be generate non-captures. And this explains all the strange values that we have. If you take a look at the new start position here, now it's 93 seconds. If you think about it, except from the root position, there we look at all the moves, but in the search down there, we never made a non-capture pawn move. We have only capturing pawn moves. And of course in the starting position there are no pawn moves at all that we can do. In the root position we will make all the moves, but after that we will not have so many moves to choose from, especially in the start position. But even the other positions will have much less moves to choose from. Here we have much more reliable numbers. We can see 93.9 seconds go down to 43.5 seconds, and that's okay. And the other go downs in the same manner. And now we have an effective branching factor that is much more, well, I trust it. But the trend is the same. We cannot compare these with the before the bug and after the bug. But the trend is still true. We get quite a lot of performance just to introduce a transposition table with not perfect move ordering. Just put the transposition move first. We have the killer, of course. I will make more tests when new features are implemented, and I hope it will be bug-free. Okay, see you next time.